Rollback. How do we, given the TXID of an action that is being reversed, our task is to bring the database to the state that it was at before that happened, before that action happened. So we can see in the hello world example for the hello world protocol, we log minus, we're taking away this transaction out of the bridge. So like, if there's a transaction that happens and it's makes it into a block, and we run this forward, or maybe it happens live, maybe it's not even confirmed yet. We run that transaction forward. It's like writing a database migration almost. Every transaction has to act like a rollbackable database migration, where you can run it up, and migrate down. Bring the database back to the state that it was at before the migration happened, before the transaction happened in this case, because my Bridgeport node will detect which transactions need to be in which order, and it will also detect, reorgs, chain splits, all of that stuff to it'll roll back all the transactions, when it needs to, in order to get them in the right order. The task of my Bridgeport node is to ensure that every Bridgeport bridge gets all the transactions in the right order. And if I can do that, and if you can write the logic properly, then everything will always stay in sync. There's very strong economic incentives around getting that right. It's very challenging sometimes, but what are we doing here in rollback? So for hello world protocol, the rollback was pretty easy. We are simply deleting the transaction with the ID out of the hello collection, right? With the same transaction ID. And then if it was live, we're also deleting it out of there, so we don't have multiple instances of live transactions that come in and things like that. I did not add live events to this new bridge. I don't think we need user ID here either. I'm kind of coding as I'm going along here. Line 57. When there is a send message, not only do we need to insert it, but we also need to make a live event. So if the action is live, then we create a new record in the Bridgeport events collection. And that way, I'm also going to give this a type of message. And let's also add live event support for the changing of names. I'm going to copy this. Regardless, I'm actually going to do this one a little bit different. I'm going to put the TXID and do it that way. So we're not tracking the TXID here yet. We're going to in a second. This code is going to change because we need to track rollbacks as well. You'll see that in a second. What we're going to do down here is if the action is live, so if somebody live changed their name, name change, there's the ID and the name. There, so when type is name change, I'll just make this type name actually. When type is name, there's a name field. When type is message, there's a message field in Bridgeport events. So that means that in rollback, first we're saying we can just drop it out of here, right? What we can do is search the messages collection for the txid. Now we don't have access to the whole transaction inside of action there. We only have action.tx.h. And we can just search for the ID. Whoops, state.read. So we're saying look for a message with this txid, and if search then we can delete it. So same syntax here, same fields there. So what does that do? Does this work? Here's another question. So I'm going to delete this here. I'm going to review this code very thoroughly at the end, so hopefully everybody can get a better understanding of it. If we are deleting a live action, then we can just drop it based on its txid as well out of that. And that applies to messages and name changes, live events associated with them. So we've got to search for that. But if we can't find it, well, then it must be in the other collection. It must be in the names collection. Somebody made a name change and it didn't work. So I reviewed the insert stuff. We're inserting based on the Bitcoin transactions. We're transforming those Bitcoin transactions into updates to a database. Now for rollback, what we're going to be doing here is bringing it back to its initial state. So if this transaction never were to have happened, then what would the database look like? So what we first do is we, as I said, we search the messages collection. So we say, well, is there any message with this txid? And if there is, then it can be deleted. Now we've brought it back to its initial state, right? That's all fine. And we come down here and we also say, well, if there was any live event that happened with the same txid, then that gets deleted too. However, what happens if somebody changes their name from Fred to Bob using the setName protocol verb? And now that transaction that changed their name from Fred to Bob gets rolled back. And that kind of creates a problem, doesn't it? How do we know, how do we bring the database back into what it would have been if that transaction were never to have happened? That's what the rollback function needs to do. You need to bring the database to a state as if the rollback never were to have happened to begin with. So we need to bring back Fred. So Fred turns into Bob when the transaction runs forward. Bob turns into Fred when the transaction runs backward. But how do we even know that? We ran an update. And in the update, what did we do? Well, if we look at process, when we made it run forward, we call update, and we didn't preserve the old name, we just updated. We overwrote that name, right? So what we need to do is we need to track previous versions of transactions. We need to track previous versions of state in current state. And that way we can always go back to the previous state when we need to. How in the world is that supposed to work? And the answer is we need to have previous versions as a property of each, as an array property of each document in our database. So this is just one way of doing it, but however you can get your state back, when we create a new name, there is an empty array which contains the previous versions. And it's empty because there's no previous versions when we create. Now there can still be a name field. And then we have the previous versions of the name, right? When we update, what we need to do is we need to set the previous versions as well. So the name can be the new name, right? Previous versions needs to be, you can go ... x previous versions, that's fine. And you also can say x.name. So what we're saying is put the previous whatever x.name was, because we're saying x, right? And we're saying put that there. But it's even more complicated than that. And I'm just going to do this, and then I'll try to explain it a little bit. What we need to be doing is keeping track of the TXID as well. Because given the TXID, remember, we need to be rolling it back based on the TXID to what it was before. So we're going to say current TXID. In the previous version, remember, x.txid, because x is the previous one. So we're putting a new previous version object onto this array, which contains the TXID of the previous transaction, which set the previous name, and the previous name itself. And we also want current TXID, which we know for the new one on the update is action.tx.h. So we've got a previous version there. Now we can kind of insert. So what happens? Think about this. What happens? And also when we create, we need to put current TXID. So I'm going to copy that. The reason why we don't have to do this with messages is because there's no updating a message. If you add edit history, which would be a good challenge for a message, so you could edit the message after you send it, you would need to track the TXID of the previous edits, so that given a TXID that needs to be unwound, which is always the current one, by the way, you're never going to unwind a previous version while you have the current one in the database, because everything gets wound backwards in the correct order, and everything gets wound forwards in the correct order by Bridgeport. You've got state.create, collection names. So we track the current TXID when the name was created, right? And then when the name is updated, we take any previous names and put them below on the previous versions. We create a new previous version which has the current TXID from before, as well as the name from before. And then we update the current TXID and the name. And remember, underscore ID never changes. Underscore ID is always the user ID of the user. So the reason why we don't have to track that as well in previous versions is because as long as it's never going to change, it never needs to be tracked. So now we have the information necessary to roll back our name in rollback. So we tried to find it inside message, right? I mean, it would have been much simpler if we could just find it in message and then drop it. If we find it inside of name, where it will be, because it's always the latest one, because everything runs in order, is search equals await state dot find read collection names and find current TXID of action.tx.h, the one that we're rolling back. So we try to find the one, right? So we've looked in the message collection. And if it was there, oh, and it's saying search is already used, so I'm going to say name search. Name search, okay. We're saying first look in the messages collection, right? Is it there? If yes, it gets deleted. If no, the only other collection is the names collection, so we're going to do a name search. So if it wasn't in the name collection, then we've got an error. So we're trying to delete something that doesn't exist. That does not exist. Convenient. Okay. Trying to delete something that does not exist. So, now at this point we know we have search, right? If there is no previous version, right? If search.previousVersions.length is 0, then delete the current one. Why is this okay? Well, if in process a user comes along and they make a name, search equals array state.read collection name find user ID. So if we're just now making a name for the first time and putting it in the database, and it's got nothing behind it, there's no previous one to roll back to, and then we roll back that transaction that initially created that name, then it's okay to delete the record. And I think that should make sense. A user created a name for the first time, so we inserted the record. Now we need to make it as if that user never created that name. Therefore, we need to remove the record and bring the database back to a state in the rollback where that record never existed by deleting it. So if there was no previous versions, then we can simply delete the name out of the collection. But if there was a previous version, const previous version equals I mean name search. Name search.previousversions.link. So that's the element, that's the first document from the name search, right? There's only one document, by the way, ever with that current TXID. There's only one, TXIDs are unique. Name search state.delete in that case, action.tx.h. The previous version is name search dot previous versions dot pop. Push or wait, how are we doing this? Are we saying that the newest version is on the top of the array or the oldest version is on the top of the array? I don't actually know. Let's say I want to use pop. So if I say let x equals 1, 2, 3, or 1, 2, 4, right? X dot pop 4, x 1, 2. That's what we want. So I'm going to go back to process and actually change the way this is ordered. I want the newest one to be on the bottom of the array. Right now we're putting the newest one on the top. There. Now I can use dot pop. Maybe there's an opposite of dot pop, but I'm going to use dot pop. Now we've got the previous version, don't we? So we can update it. Keep in mind, what does dot pop do? Dot pop will remove. So x was originally 3 elements long. Now it's only 2 elements long. That's very convenient. And we get the first one back. And we get the one at the end back. So bring it back to how it was before. Find the one with that TXID, map it, and also we need the collection. Just going to copy this. Map it, x. So, what gives? Dot 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 x. To bring it back, the current TXID is previous version dot current TXID. The name is now previous version dot name, and the previous versions. Remember, we've just popped the old previous version off of the previous versions array. So we can just use name search dot previous versions. So this is the proper code for rolling back. Let's suppose, as I said before, Bob changes his name to Fred. So first, Bob makes a transaction. I'm going to run through all this. So try to follow along and rewatch if you haven't followed along. You know, this is probably very long, so definitely pause the video several times and whatnot as you go through here. Bob makes a transaction using this Bridgeport bridge that sets his name to Bob first. So this is the first thing that Bob does with his user ID. So we're going to search for Bob's user ID. We're not going to find anything because Bob hasn't made a set name call with this user ID yet. So we're going to skip down to here. Okay. We're going to insert into the database a collection user, right? Collection names. We're going to insert Bob's user ID. We're going to insert the current TXID. We're going to insert the name Bob, because that's what Bob is doing at the beginning, is making his first name as Bob. And we're going to say there's no previous versions. Make sense? If you get that, then move on to the next part. Bob is now going to change his name from Bob to Fred. We get a new transaction. We run the search with the same user ID that was Bob's user ID. Do we get a result? Yes, we do. What are we doing when we get the result? We're taking an update. We're saying that the collection names is being updated. For Bob's user ID, for this user's user ID, we're saying put everything there. We're saying put the new name as Fred. We're saying put the new current TXID as the transaction that changes Bob's name to Fred. We're saying add a new element to the previous versions. And the new element is going to have the name of Bob and the current TXID of Bob's previous, when he first created his name, transaction. So now, what does Fred's record look like? Well, Bob changed his name to Fred, so now, at this point, the record would look like current TXID, the TXID of the transaction where Bob changed his name to Fred. The name would just be Fred. ... X would be the user ID of this user. And there would be one element in the previous versions array. That previous version would be current TXID, the transaction ID of the transaction where Bob originally made his account. And the name in that previous version object would be Bob. So that's what the record in MongoDB would look like when Bob popped up, first made his name as Bob, and then made a new transaction to change his name to Fred. Now, pretend like we have that scenario. Bob first popped up, made a transaction to make himself Bob, and then made a second transaction to make himself into Fred, having a previous version. We're going to run through what it would look like to roll back both of those transactions and bring the state back to how it was. If that transaction ever needed to be rolled back, my Bridgeport node would let you know by calling the rollback function with the TXID of the transaction that needs to be rolled back in the correct order, mind you. So you're never going to see that initial transaction where Bob made his name as Bob try to be rolled back when Bob's current name is Fred. That will never happen. If that happens, I've done something wrong. So, transaction A goes, then transaction B goes. When you roll back in time. First transaction B gets rolled back, and then transaction A gets rolled back. So we did AB, now let's do BA. Incoming transaction, line 1. State in action. Log the TXID. We're searching for messages, but no, this is not a message. We are rolling back the transaction where Bob's name was changed from Bob to Fred. Will there be a result? No, there will not, because this is not a message. This is a name change. So we move into this else block here. Line 17. Name search. State.read. Find me a record where the current TXID of that record is the TXID being rolled back. Why don't we have to look in previous versions? Well, because the latest version is the only one that will ever be rolled back in order. So the current TXID is the only place we have to look because we change the current TXID every time we put in a new version. So we run a search. Which record is going to be found? If there's no name search, then there's an error. But the record that's going to be found is the record where we set the current TXID to that transaction where Bob changed his name from Bob to Fred. That transaction is now inside of this name search variable. Now, remember that we have one previous version in there. So is namesearch.previousversions.length equal to 0? Line 27. No, it is not. Because remember I said that previous version is going to be the one where Bob's name was Bob when he first made his thing. So we skip down to the else block, line 34. The previous version is what we want to get back, because remember what we're doing is we're rolling back Bob's name from Fred back to Bob by undoing and bringing the database into the state that it was before that transaction ever happened. Previous version equals namesearch.previousversions.pop. And you know what .pop does onto an array in JavaScript. It mutates the original array, deletes the last one, very conveniently for us, and returns it. So what is previous version? What is the variable on 35? What does that equal? That equals the current TXID object. That equals the object that contains the TXID of Bob's initial transaction where he first popped up and set his name to Bob. And it contains his original name as being Bob. State.update, collection names. We're finding the current TXID equal to the TXID that we want to roll back, and we're updating it. X.x, that's the user ID of this user. The current TXID is now the TXID where Bob originally set his name to Bob. The name is now the previous version name, which is Bob. And this one can be a bit tricky, but previous versions is equal to namesearch.previousversions. And that actually contains one less element. So if there was one element on there before, because we used .pop up here, now it has 0 elements. And we're inserting an empty previous versions array to roll back the change to the state. So we make that update. And at the end, and we'll ignore this for now because we're just saying if there's any live things, we do that. At the end of the bridge, at the end of the rollback function, congratulations, we have successfully rolled back the changes to the database for one transaction. So now that database is as it was before Bob changed his name to Fred. Now he's just Bob, and there are no previous versions in his record. It is previous versions is an empty array. I'm going to run through this one more time. And we're going to roll back the original, where Bob originally made his name to be Bob. Incoming transaction, line 1. Log the TXID. Is this a message? No, it is not. It is a name. So the search will have no results. Jump to the else block, line 17. Search for the name where current TXID is equal to the TXID being rolled back. Now remember, TXID being rolled back is now the one that happened before where Bob originally set his name. But when we went and updated it before, we set the current TXID back to that value. So now it's correct. When we search, what will we find? There will be a result. But previous versions.length will now be 0 because before we deleted that previous version. Now there's nothing in the previous versions array. Nothing in the previous versions array because this is the transaction where Bob for the first time came up and set his name as Bob. So we are safe to simply delete the record from the names collection. Bob's record no longer exists. We're deleting it based on its current TXID, and we're done. Now the database is such that it was before Bob ever existed. We have defined a method by which we can roll forward in time, as in migrate up, And we've also defined a method by which we can roll the state backwards in time, as in migrate down. That's quite a lot, isn't it? It's quite a lot of things to consider. We have to do a lot of this rollback stuff right now. I will say that in the future, when you build Bridgeport bridges, I hope to set something up so that I can automatically know what the state was before, so that you never have to think about this. But for the time being, every Bridgeport bridge that runs on my Bridgeport node needs to define a method of bringing the state back to how it was before transactions happened, given their TXID. And that way we can deal with things like reorganization, etc. You can manage this however you want. You can store whatever data you need to store, previous versions of things, but the point is that the current state must always be a superset of the previous state, such that, given an unwind command, you can arrive at the previous state given the current state. If you can arrive at the previous state given the current state, you'll be in a position where you're able to roll back changes. It needs to contain all of the information associated with those things. I think that's good bridge design. But in the future, like I said, I hope to do that automatically for people. I don't have that done yet. All right. Let's take a step back. In fact, I'm going to take a break from recording. I've been recording for quite some time. I covered the setting up of the initial bridge, and I covered the building of a bridge transformer, including a rollback logic. This bridge can set this bridge can enable a user to not only send a message, but also set their name. And that way we can have screen names on a thing called Postboard. I haven't even gotten to the UI yet. We're not even using this in a UI yet. So the bridge transformer, after we have rollback and process completed. So process is rolling forward, of course, putting things into the database. Rollback is, well, rolling back. And we have our filter done inside bridgeport.json. We have our repo token inserted, created the bridge in the dashboard, and we looked at some documentation for what it means. I guess I'll read through the step 2 again, just to kind of recap what we've done in step 2. You write code that transforms these transactions into database commands. This code is called a bridge transformer. We are transforming the filtered version of Bitcoin into a certain format, ascribing certain meaning to these transactions. The specific meaning in this case being, I set a name for my user, and I send a message on behalf of that user. Next, we're going to talk about step 3, which is the bridge reader. And that bridge reader will enable you to read from a database. But first, I'm going to take a break, so I'll be right back.